Hello, this is a shorter video on simulation with building up on the original calendar example where the only uncertainty was in the demand, and we generated it from a normal distribution. So the next example is doing the same thing, but if you recall the triangular distribution, we're going to replace the normal distribution with the triangular distribution. And this is really the efficient way to do it, is to put the inputs of the distribution on the spreadsheet. The first example, we put the mean and the standard deviation of the normal distribution inside the formula, and that's not advisable. You want to put the inputs somewhere else and refer to them. So the only changes here are substituting the triangular distribution for the demand. And the other thing is we put the demand generated from the normal distribution by doing it directly into my model right here, not putting a different cell and then referring to that cell. And so we're generating it from a triangular distribution. This is the syntax, and we're rounding it to 0. So, and then the rest of the formulas are pretty much like the first example, and we generate a profit. The third change is we can get type risk min, just choose what metrics we're interested in, 5th percentile, 95th percentile, and put it in our spreadsheet. But that really is not necessary. It's more work because you will get that in the quick report. So you will see that after you run this model with the new triangular distribution, we get the snapshot that copy-paste the grid that we put in the sheet, not the interactive window, but a picture of the interactive window here. And we did the quick report. And so it's not necessarily to put formulas when you can get all this information in a quick report. You get all this information plus some charts of the typical charts that come up with the interactive window. But you get all this information, so no need to do it right here unless it's one of your preferences. So if we go to at risk, we see that we ran this for one iteration, for one simulation, 200 iterations, but with a triangular distribution. The other example that builds on it adds more complexity, and so that's the solution for it. We're adding a triangular distribution for demand at regular price and demand at sale price. So we're planning to sell it at regular price and then give 50% reduction and sell it at 5. So it's a slightly different model. Rather than return it to a supplier, we sell it at half the price. And we see we have estimated a triangular distribution for regular and sale price. But we also have supply uncertainty, which is a big topic in supply chain, because we're looking at, well, yeah, they can provide us with a minimum of 125, most likely 200, maximum 250. In the previous two models, we just said we're going to order 200. And so that is certain. We're not going to order more or less. But what if the supplier says, well, I can't provide you with all 200, but here's the possibilities I can order. So we generate a triangular distribution based on that. So now we have to run this simulation 1, 2, 3, 4, 5 times using these order quantities that I would want to use. And so maybe I order 150, I order 175, 200, up to 250. And so the order quantity, there is a formula in at risk called risk sim table D10 to H10, which runs this simulation 5 times, once with each of these order quantities. So then now the model changed. Now we have more cells here. And so we have a maximum supply that can come from the triangular distribution. We have the actual supply that would be the minimum of B14 and order quantity. This is the order quantity. So this makes it more real. Is it, we generate the maximum supply and we have the order quantity. So the first simulation is, what if I order 150? How much can the supplier send me? So in the first iteration, they send me more, actually, 192 generated from this triangular distribution. And the actual supply is 150. So the simulation generates 192, actual supply is 150. So what is the cost? So you have to put an if formula here. If B14 is greater than the order quantity, then the unit cost 1. And if it is less, then its unit cost 2. So another element that makes it more complicated is, if I order 150, and the supplier sends me less than 150, there is a penalty for the supplier of 25 cents per calendar. And so, but if they send me 150, I'm good to go. So you have to model that with the cost function with if statement, as you see here. And so the actual supply is the B14 and the order quantity, the minimum. The cost depends on which cost I'm applying, if it's more or less than what I ordered. Then you generate a demand at a regular price and a demand at a sale price, similar to what you did before in the first two models. And the revenue would be the regular price and minimum C14, E14, so minimum of the supply and the demand. And at the sale price, so this is the same like before. You generate a demand at the sale price. You find, do you have any more than you ordered? The demand was less than what you ordered. Do you discount it at 50%? So this is a very different model than just giving you the total profit with a refund on ones you send back to the supplier. Here you're saying, I don't want to send back to the supplier. I want to just discount it 50% and sell it myself. And so with three uncertainties, the supply, how much they supply you, demand at regular price, and demand at sale price. And then your profit is a combination of all that. And so that's how the model changes. And because you have now risk sim table and you're running it 5 times, when it comes to this and you just run it, it would give you 5 outputs, one for each simulation with each order quantity, a quick report for each of these simulations. And so then you can ask questions from the interactive window of each simulation and ask the different probabilities and expected outcome. So this is the most complex of the 3 models we covered. And like I said earlier, these are models based on analytics and what the values generated. I will be making my decisions based on these expected values, other metrics as well. There are many other options to look at in advanced analysis, but we cover mainly the basic. If you want to learn more about it, you need to look at it on your own and watch the videos and see what advanced features there are. But at least in this one, we are looking at some of the basics. So we took a model from basic 1 distribution all the way to 3 distributions, and the model is just this one line, putting the right formulas in here, designating this as your risk output, the profit, and we're looking at expected values of this profit under whatever, if we decide to run 200 or 1,000 simulations of each of these, then that's what we run. So thank you.